Okay, today we want to talk about algebra, the basics of algebra for the purposes of analyzing the linear demand and supply curve. Now, this is called a Cartesian plane. It has got the y-axis, which is this, and the x-axis, which is that. Now, on the right-hand side, the x-axis is positive, so it will be 1, 2, 3, 4, and so forth. On the left hand side, the x-axis is negative, -1, -2, -3, and so forth. Now, what you must note about all of the x-axis is that y is 0 anywhere here on the x-axis. The same thing applies with the y. At the top here, the y-axis is positive, so it will be 1, 2, 3, and so forth. And below here, the y-axis is negative, -1, -2, -3, and so forth. By the same token, everywhere here on the y-axis, x is equal to 0. Now, we use this to depict a relationship between two variables. So in this particular instance, it's x and y. So if we have something like this, where y1, x1, y2, y3, x2, x3. If we want to know the relationship between y and x, we can draw a curve here that shows that relationship. So in this particular curve, if we want to show that y is equals to x, it means that everywhere where y is a particular number, x is the same number, right? The opposite is actually more true. So x, wherever x assumes a number, y assumes the same number. For example, so where x is 1, so x is 1 everywhere here, like this. At the bottom and the top, you just align into the number 1. X is 1 everywhere there. Now, y will also be 1. Y is 1 everywhere here. Now they meet here. You can do the same thing with 2. They meet there. 3. They meet there. Now you have a line here. It's like a 45-degree line in the middle of the 2. This line is at this particular point showing us the relationship between x and y. And because it is a straight line and it runs exactly in between, it is telling us that y is actually equal to x. So this is the most simplest of these forms to show a relationship. So we've done y is equal to x, and I'm going to draw half of the Cartesian plane with the positive sides only, positive sides of y and positive side of x. We're leaving out the other parts. We're saying it runs in the middle here, where you have these 1, 2, 3, 1, 2, 3, where x is 1, y is 1.